Hello. So we are going to be talking about object-oriented programming, or at least a brief intro to it in this video. This is going to be exciting. I know this. It's the title of this course, even though I did say at the beginning of the course that for about the first half, we're not really going to be talking about object-oriented programming just yet, but we've now reached the point that we are ready. So without much further ado, let's get into it. All right, so before we just give me another 5 minutes before we jump into our OP, we want to do a little bit of review, and then hopefully that would also motivate for why we want to start object-oriented programming. So, what have we learned up to this point? Well, quite a few things, but some of the main thing is we learn about data types. That Python has all these built-in data types: int, float, string, list, and tuples. I think that's what we study so far. And then we have variables, which are names that are associated with values. We have conditionals, if, else if, and all that. We have loops, which are for loops and while loops. And finally, we have just completed a study of functions. So what can we do with these? Well, as you see, we could do quite a lot of things, right? We did a project on mortgage calculators, and we're doing another project with kind of just extracting statistic from a collection of data. So we can already do quite a lot with what we've learned. Now, then the question is, okay, what can we not do? I mean, given all that we've known, particularly in terms of the types of data that we can represent, right? So we can represent these type of data so far, but so what can we not do if all we have are these type? Okay, well, so what we cannot do is that it's really not easy, if you think about it, to represent complex things um, that are consists of multiple attributes, such as, okay, think about in a geometry class, right? If you want to represent a point on a 2D plane, what can you what do you need? Well, you need two numbers, right? We need an x and y. So they are numbers, but they are kind of um, they are related, right? If x all by itself doesn't mean a whole lot, and y by itself doesn't mean a whole lot, right? You have to put x and y together, then together they represent a point, a particular place on the 2D plane, right? How about a more complex example, such as a car? A car, well, depending on whether you're in a dealership or you're actually designing a car in a manufacturer. But let's say if you're a dealership, a car is a bunch of things, right? You probably want to start with a brand and a model, right? That kind of nails down on on which car you're looking at, and then probably the year that it's built. That also is another attribute of a car, and then obviously other things like the color and the price and all that. All those information together, they represent a car. Okay, so it's not that easy to kind of represent a car given what we know so far. We can try. So let's say, to represent one car, we can have a can have a variable that represent the brand for that car. We have another variable that represent the model, and then another variable that represent the year, right? So maybe a few of these together can represent a car. Um, and then we can have maybe another set of variable that kind of looks similar that represent a different car. So as in this case, I kind of prepend the name. So instead of we say, brand one, that's for car one, brand two, that's car two. I don't know where these extra arrows are doing there. Now let me get rid of that. I remember. Okay. So yeah, we might go with one convention to use a bunch of variables that represent different cars. Now, what are some of the problems with this particular approach? You kind of think about how you will be able to use these um, variables, right? So I listed out a few of them. So the first one is, even though all of these variables, they are kind of inherently part of a particular car, but by using separate variables this way, there's really, between these variables, there is no inherent grouping or relationship between them, right? So that's one problem. Another problem is, uh, uh, if some of you probably notice, for the Honda Accord to represent its year, I call it year one, right? However, for the Tesla, I call it Y. Well, I mean, that's perfectly legitimate. But then that's very inconsistent, right? And after having a few cars, you're probably going to go all over the place too, and name different variables that are really meant to represent the same attribute but differently. So that's not good either. And then finally, a car really can do a lot of things, right? For example, most basic thing is it drives forward. So how do you write a function? Let's say just move forward, and we want to move a particular car forward. In this case, what is the parameter car? What represents a car? Is it the brand name? Is it the model name? Is it the color? Is it the year? Is it the engine type? And hey, maybe it's the vehicle identification number, or is it all of the above? So it's kind of it's a little difficult to actually represent a car using the things that we know so far, that we learned so far. And that's where object-oriented programming comes in. So our world, the world that we actually live in, we have a lot of these very complex things. And all these things has attributes that define them. And then all of these things can also do a lot of different things, perform different actions. So to represent these things in programming, we use this paradigm called object-oriented programming, or short, OOP for short. So in this paradigm, an object is consisted of basically two sets of things. The first thing, as we already kind of talked about, are attributes. So these are basically the data, the information of the object, right? We've seen examples of that for a car. It's the brand, model, year, price, etc., etc., right? And then also, an object can also have a collection of methods. Well, what methods are? They are functions basically, but they're functions of an object. So there's a different name for them. They're called methods, and these methods are represent actions. They're basically code, right? Function is a series of code that do things. So methods are just the actions that the object can do. So that's what basic in a very basic terms what an object is in terms of programming. And kind of pictorially, which is kind of the way that I like to see a lot of things in programming. Pictorially, what do we see? To represent actually a car, let's call it car one. This is an object that represents car one, and inside this object, it has a bunch of attributes, right? But that's part of a a car object, right? It has a bunch of attributes. They all have values. And then it has a bunch of methods. They do things for this particular um, car one. Okay. So, and then car two looks different, looks similar, consistent, right? It also has the brand, it also has the model year, and it would, I mean, a car, regardless of the brand, they kind of do very similar things. They can all move forward, not forward, sorry, forward, and they can turn left, turn right, stop, and honk, and things like that. So the value for each of these attributes are different, right? This for the Tesla Model 3 is Tesla Model 3, right? Honda Accord is Honda Accord. However, the attribute, at least the name of the attributes, are consistent. So for the same type of object, we want consistent representations, even though we can have multiple objects of the same type. Okay, and the attributes, each object of the car can have its own set of attributes, and then obviously it can the object itself can perform a bunch of actions. So that's we're still kind of in the overview of what an object is in programming, but this is actually getting closer to what actually will be in the code.